In this video, I'm going to show you how to evaluate this double integral in this region here. And this region turns out to look like this. It's this region here. So to evaluate this double integral, let this be u. So let u be this, and let this be v. Let that be v. So by doing that, this becomes a lot easier to work with. It just simply becomes this. So currently we are in the x, y realm. When you make this substitution, the integrand becomes easier to work with, but then you've got to make some sort of adjustment, what's called the Jacobian. So we're going to evaluate the Jacobian later on. But then you also need to make the adjustment in your region, because currently we are in the x, y realm. By making this substitution, this region will get morphed into something new. I don't know what. And then we got to make the adjustment in our region. So to work out this adjustment in the region, abandon this and try to make x the subject and y the subject. Work in terms of x and y rather than u and v. So for example, we can use these two equations to eliminate the y. So if you get this equation, add this equation, it will then give you this, because these two will cancel each other out. So now make x the subject. Make x the subject. So x equals this. And then looking at these two, well, let's put this back into here. Well, just do whatever you want. Just eliminate x. Just eliminate. Well, make x and y the subject. So we would put this back into here. So now this thing here will then become this. So now we can make y the subject. So y turns out to be this thing here. So now we've got x and we've got y. So let's start again. Hang on. So we start out with this, apply this transformation, and then we abandon this and work in terms of x and y. Okay, so now let's investigate what happens to our region. We need to investigate this region. This region will get morphed into something else. We need to investigate this region. So let's consider this line, this diagonal line. Well, this diagonal line is y equals 1 minus x. So now let's see what happens to this line in the uv realm. So let's investigate. So let's put this into the y and put this into the x, and then we can see what happens in the uv realm. So that will then give us, so this thing here will then become this. So now make v the subject. So making v the subject will then give us this. So v equals 1. So now we know that that under this transformation, this diagonal line becomes v equals 1. So it's going to be v equals 1. So we know that this line gets morphed into this line here. So next step. So we know that this line gets morphed into this line. So now next step is to consider this line here. So this line is really x. Sorry, let's now consider this line here. So this line here is x equals 0. So x equals 0. So put this into the x. So that will then give you this. Rearrange it to make v the subject. So v equals minus u. So that means it looks like this. V equals minus u will be this diagonal line here. Will be this diagonal line here. So this line here will get morphed into this diagonal line here. Okay, so that line there will get morphed into this diagonal line here. And now let's investigate y equals 0. So let's investigate. Let's investigate this line here. So that line there is y equals 0. So put this into the y. Then this thing here will then become this. Make v the subject. So v equals u. So you've got another diagonal line. So so y equals 0. So this line here becomes this line, and then this line here becomes this line. This diagonal line here becomes this line here. So under this transformation, this region here will get morphed into this region here. So let's start again. So now now we've got our region. We can now make our adjustments. So looking at this, v u, so that's going to be v equals something, and then u is on the outside, so u equals something. But then you don't really want to work in terms of v, because you don't want to move like this, because you've got to set up two integrals. You've got to go from this diagonal line to v equals 1, and then now you've got to look at this diagonal line as opposed to this one here. So you've got to set up two integrals. Rather than moving in the v direction, think about switching these two around. So now if you work in terms of u, it would be a lot easier. It's just one integral. See that? All the way through. It's from one diagonal line to the other diagonal line. Whereas if you move in terms of v, then you've got to set up, this is one integral, and then this will be your second integral. So it's easy. My point is that it's easier to work with du and then dv. So let's work with this thing here. So so set up this integral, moving in parallel to u. So that would be you doing this. So you can see that you start at this diagonal line here. So so that would be, well, you're working in terms of u. So it's going to be u equals something, and this diagonal line is u equals negative v, so make u the subject here. So that would be from u equals negative v, and then you stop when you get to the other diagonal line. So you stop when you get to the other diagonal line, or this other diagonal line is when u equals v, when u equals v. And then now thinking in terms of v, so you're scanning from v equals 0, and then you're scanning all the way through to v equals 1. So that's v equals 0, scan all the way through to v equals 1. So now from here, under this transformation, it will then take us to here. Now we need to take care of this adjustment, this Jacobian. So now we need to compute the Jacobian. So the Jacobian is given by this, and remember what goes in here is the absolute value of the Jacobian. Well, anyway, let's compute the Jacobian. So Jacobian, partially differentiate x with respect to u. So x with respect to u. So when you differentiate this, it would then become a half. So now differentiate x with respect to v, so that would be positive a half. And now differentiate y with respect to u, that would be negative a half. And then differentiate y with respect to v, so that would be positive a half. That's this thing here. So work out the determinant. So it will be this times this, and then take away this times this, which turns out to be a half. So now we can put this a half into here. So that would be a half. So now we are currently at this stage. So now we are currently at this stage here. So we started out with this, make the transformation, now we are currently here. So now a half is a constant, so let's drag it out here. So that would be a half. But then a half is a constant, so let's drag it out even further. So bring it out here. So this thing here becomes this, Now we've got to look at the inner integral and integrate it with respect to u. So when you integrate this, it would be this thing here with respect to u, from u equals negative v to u equals v to u equals v. So now, hang on. So we can now put this into here. So that would be v over v, which would be 1. And then you take away and then put this into here. That would be negative 1. Let me just tidy this up. This becomes this. This becomes this. So now integrate it with respect to v. So when you integrate this, it will then become this. Integrate this, it will then become this from 0 to 1. From 0 to 1. So now put 1 into the v. So that becomes this. Take away. Hang on. And then you put this into. You put the 1 into here. That will then give you this. And then take away. Put 0 into here, which will be 0. Put 0 into here, which will be 0. So this thing here will then become this. And then it's blah 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 blah. Your final answer would be this. Okay.